Solving quadratic equations by completing the square. This is a Leaving Cert higher level question. First, let us think how we might represent numbers and x's and x squareds using algebra tiles. So we could represent x squared plus 10x equals 39, maybe something like this. How could we make a square on the left hand side? Well, if we split the 10x into two groups of 5x, we begin to form sides of our square, but it's not yet complete. To do that, we would need to add 25 more units. So we do the same to both sides. And now we see that on the right hand side, we could also make a square, because 64 is 8 squared. By comparing these squares, we see quickly enough that x equals 3 is one of the solutions to this problem. This method was used more than 1,000 years ago by the father of algebra, Al-Khwarizmi. Now let's do the same problem again, but this time using purely algebra without the drawing. So we could use the array method to figure out that the related complete square, or the one that begins x squared plus 10x, is the square x plus 5 to be squared. So with our equation, we add 25 to both sides to complete the square on the left hand side. So now we can rewrite the left hand side as x plus 5 to be squared. Be careful now, when we square root both sides, we realize that there is a positive and a negative answer to this. So this gives us two solutions, that x could be 3 or also it could be negative 13.